Hi guys, and welcome to this new video. Today we are going to see what is a linear equation system with two unknowns. Okay, as I told you the last video, a linear equation, it's an equation that is represented graphically in a straight line. Okay, and when we're talking about a linear equation system, is because we don't have just one equation. We have two equations. Okay, so look at this. We can have three different cases. For example, this is the case number one. What about, well, let's write the Cartesian plane xy, and we are going to have two linear equations. Maybe this is going to be the equation number one, and this is going to be the equation number two. Okay, what happened over here? As you can see, we have one intersection with both equations. That intersection is going to call solution. So this is going to be the case number one. We are going to have a unique solution. What is called unique solution? Because we have only one point of intersection. Okay, let's continue with the case number two. What about if I have x and y? Maybe this is going to be the equation number one, and this is going to be the equation number two. What is the principal characteristic that you can see? Both equations are parallels. It means that they are not going to join, never. They are not going to have an intersection. In that case, we are talking about case number two. In case number two is no solutions, because we don't have intersection. Remember, each intersection is going to be a solution. In that case, it's no solution, or it doesn't have a solution. Okay, and here we're going to have the third case. We're going to make the Cartesian plane x and y, and this is going to be the equation number one, but the equation number two is going to be above of the same equation. Okay, so both equations are gonna make the same straight line. So this is going to be the case number three. What do you think that is the case number three? Remember, here is no solution because we don't have an intersection. Here is unique solution because we have one intersection. My question is, how many intersections do we have over here? As you can see, all the points of each equation are going to be repeat, and each point is going to be a solution. So it means that we have an infinite number of solution. Okay, so we can have in a linear equation system with two unknowns, we can have case number one, case number two, or case number three. Okay, let's try to solve this linear equation system with two unknowns and with two equations. Okay, we have three different options. The first option that we're going to see, it's called by elimination or reduction. Okay, this is the first one. It means that you need to eliminate or reduce to just one variable because you are going to eliminate another variable. To do that, it's very important to see if it is possible, first of all, to do it directly. First of all, you need to see that it's impossible because, for example, in the case of x's, if you add 5x plus x, you are going to have 6x, so it's impossible. In the case of y, if you subtract 3 minus 2, is going to be just 1, so it's impossible too. And finally, directly 13 and 6 is going to be 19, is going to be possible. So This option is not possible, just to eliminate directly. Second option is gonna be, well, if you cannot do it, what about if you multiply one number and then you can become the variable with the same number but with different sign, for example. What about if you can you multiply 3 times something and get 2? The answer is not. Can you multiply 2 by something and becoming 3? The answer is not. So we cannot work with this part. What about this one? Can you multiply something by 5 and become in 1? Well, the answer is not. But what about if I multiply 5 times this one and I can multiply again 5? The answer is yes. So here it's very easy. Just multiply times minus 5. And then you are going to have this one. Minus 5 times x is going to be minus 5x. Minus 5 times 3 is going to be minus 15y. And minus 5 times 6 is going to be minus 30. Okay, this is going to be 5x minus 2y and equal to 13. In that case, we're not going to move anything. Alright, we're going to have exactly the same. So here, we're going to eliminate this part. Okay, so here we eliminate and reduce to just one variable. If I add 16 and 2, in that case we're going to have minus 17y because it's an addition of two negative numbers. And here is a subtraction. If I reduce 30 minus 13, it's going to be 16 also. But the huge number, the biggest number is 30 with negative. So negative is going to be the sign of the answer. Okay. So here I'm just gonna pass this 17, that is multiplying is gonna pass dividing. So y is gonna be just 1. Positive because minus over minus is positive. Okay, so here we got the first value of the linear equation that we are looking for. Okay, this is the first value. Now, what I'm gonna do over here? Okay, I'm going to choose the first or the second, whatever you want, equation, and substitute the y value to get the x value. I'm going to take the first one, because x originally it is just x, so that's why I'm going to choose the first one. If I choose the second one, I need to clear the x because it has 5, so that's why I choose the first one. So I'm going to write x plus 3 times 1, because y is 1, is equal to 6. So x is equal to 3 by 1 is 3 positive, is going to pass negative. The x value at the end is going to be 3. Okay, if you got both number, I mean x value and y value, it means that we're talking about the case number 1. What is the case number 1? Let's remember, unique solution. Okay, I'm gonna write over here unique solution, and that unique solution is x3 and y1. Okay, so this is the case number 1. Right now, what we should do later? Okay, how to know that I'm right? Because I just did some algebraic operations, but I'm not sure if it's right or not. So what you should do is very easy. Let's substitute in equation number 1 and in equation number 2. And if you got 6, and 13, it means that you are right. So let's start with the first one. The first one is x plus 3y is equal to 6. Let's substitute x, that is 3, plus 3 times 1, that is y, is equal to 6. 3 plus 3 is equal to 6. 6 is equal to 6, so it means that I'm right. But it's not enough to do it just with the first equation. Let's make exactly the same with equation number 2. Okay, this is going to be 5x minus 2y is equal to 13. 5 times 3 minus 2 times 1 is equal to 13. 5 times 3 is 15. 2 times 1 is 2. This is equal to 13. And 15 minus 2 is 13. So if 13 is equal to 13, it means that I'm right. And it means that I'm talking about unique solution. And this is the solution of this linear system. Okay, linear equation system. But this is just the first method. The second method to solve this system is called by substitution. Okay, the first step that we should do in this technique is that you need to choose one equation. Here we have equation. I'm going to write here equation number 1 and equation number 2. You need to choose one equation, whatever equation you want, and then you need to clear one variable. As you can see, the easier one is this one, because this variable, it's easy to clear. So that's why I'm gonna take this one, and then here I'm just gonna rewrite x plus 3y equal to 6, and then I'm gonna clear this variable. X is equal to 6. This 3y is positive. I'm gonna pass negative, and then I'm gonna get another equation. This equation is gonna be called equation number 3. But as you can see, equation number 1 and equation number 3 is the same equation, but in the different order or cleared. Okay, so if this equation and this is equal, so I'm going to substitute but in the equation number 2, in the equation that I didn't choose at the beginning. Okay, so I'm gonna substitute over here, and then I'm gonna write 5x minus 2y equal to 13. And what I'm going to substitute? Well, I'm going to substitute the equivalence to x. Here x say that is 6 minus 3y, so that's the thing that I'm going to substitute over here. Okay, I'm gonna rewrite, instead x, I'm gonna write 6 minus 3y minus 2y equal to 13. And then I'm going to develop that multiplication. 6 by 6 is 30, minus 6 by 3 is 15y, minus 2y equal to 13. I'm gonna let the variables over here in this way. Minus 17y equal to 13 minus because it's positive, it's going to pass negative, minus 30. So minus 17y it's equal to minus 17. Y is going to be minus 17 over this 17 is multiplying, it's going to pass dividing with its sign, and then y is going to be 1. As you remember, it was the first answer, or is the same answer that we got in the last methodology. Okay, just finally I'm going to substitute again this value where, well, in the equation, in the auxiliary equation number 3, I mean over here. Okay, and then I'm going to substitute x is equal to 6 minus 3 times y, and y value is 1. So x is equal to 6 minus 3, so x value is 3, positive. As you can see, we got the same result that in the last methodology. Okay, so we have 3 and 1. The third methodology is called by equality. In that case, I'm going to take both equation number 1 and equation number 2. Okay, and I need to select one variable to clear in both equation. In that case, I'm going to continue with x because, as I told you, this is easy to clear, and in that case it's going to be this one and this one. Okay, let's take the equation number 1. Let's write x plus 3y equal to 6, and the clear is going to be x equal to 6 minus 3y. Okay, this is positive past negative, and then I'm gonna have one auxiliary equation you can call equation number 3. In other hand, I'm gonna take the equation number 2. I'm gonna rewrite 5x minus 2y equal to 13. Let's clear this variable, the same variable that here, and then I'm gonna have 5x is equal to 13 plus 2y. This past positive, and then finally x is gonna be 13 plus 2y over 5. Everything over 5 because this 5 multiplying, not going to divide. And then I'm gonna have the equation number 4. As you can see, equation number 3, equation number 4, both are with the variable x cleared. Okay, so this x and this x are gonna be the same, so that's why I'm gonna join together, and I'm gonna say that equation number 3 is going to be equal to equation number 4. Why? Because the x of the equation number 3 should be the same that x of the equation number 4, but instead to write x, I'm going to write its equivalences. So it's going to be 6 minus 3y equal to 13 plus 2y over 5. Okay, let's clear the variable y. This, first of all, this 5 is dividing, it's going to pass multiplying, and then it's going to multiply 6 minus 3y, and this is going to be equal to 13 plus 2y. Let's develop this multiplication. 5 by 6 is 30, minus 5 by 3 is 15y, equal to 13 plus 2y. Then I'm gonna let here the variables, and I'm gonna write minus 15y, and I'm gonna pass this one is negative, it's going to pass positive. For the right side, I'm gonna stay with 13, but I'm gonna pass this 30 positive, has a 30 negative, and then the addition of these two now negative numbers is gonna be minus 17, sorry, y, and 30 minus 30, 13 minus 30, it's a division. Sorry, it's a subtraction, and this is going to be minus, because this is the highest number, is negative, minus 17. Here is going to be very easy. Just let's clear this variable. This 17 is multiplying, is going to pass dividing with its sign, and then y is going to be 1. As you can see, we got the same result like in the other examples. Now you can take the equation number 3 or equation number 2, whatever you want, and substitute the value of y and get the value of x. For example, here you can do it. You can say x is equal to 6 minus 3 times 1. X is equal to 6 minus 3. X is equal to 3. Or maybe you want to choose this one. It's supposed that you should have exactly the same result like that one. Let's see if it is right or not. 13 plus 2 times 1 is 2, and 13 plus 2 is 15 over 5, and x is going to be 15 over 5 is 3. As you can see, again, we got the same results. Finally, I'm going to explain another method to get the solution, but this is not going to be an analytic way. This is going to be in graphic way. Okay, so this is going to be graphic method. So the thing that I want to do is that I need to make the graph of both equations, okay, x and y, and then I'm going to make the system that I'm going to realize. And I'm going to realize if I'm talking about case number 1, 2, or 3. Okay, well, here I'm going to take first the first equation and then the second equation. You know that if you want to make the graph of each one, sometimes it's necessary to make the table of values and then give numbers to one variable and get the other one. through the substitution and then make the points and put the points on the graph, I mean on the Cartesian plane, and get the graph off. But I'm going to explain another easy way to make the graph of a linear equations. Okay, using linear equation, that is a straight line, you only need 2 points. Then you can calculate the position of that 2 points and then make a straight line, and that's it. Okay, which points? I'm going to calculate the intersection on x or y axis. How? Very easy. If I want to calculate the intersection of x, I'm going to suppose that y is going to be 0. And if I want to calculate the intersection of y, I'm going to suppose that x is going to be 0. Because on all the axis of x, y is 0, and the same thing happens on y. Okay? So here, if y suppose is 0, I'm going to cancel this, and then I'm going to have just 6. Okay? So this is the intersection of this one on axis of x. And here, if I say that x is 0, I'm going to cancel this, and I'm going to have 3y is equal to 6. Then y is equal to 6 over 3. This is past dividing. So y is going to be 2. Okay, so we have the intersections. 6 on x and y on 2. Let's see. 1, 2, 3, 4, 5, 6. This is the intersection. Okay, and here and y is 2. 1, 2. This is the other intersection. With both the intersection, maybe you can take another pencil or pen or whatever you have with your hands, and then you can make the straight line over there. There we go. Okay, this is the equation number 1 graph. Okay, with its intersections. Now let's continue with the other one. I'm going to suppose for one way, if I want the intersection on x, that y is going to be 0. And for the intersection of y, I'm going to say that x is going to be 0. If y is 0, this is going to disappear, and then I'm going to have 5x is equal to 13. Okay, so x is going to be equal to 13 over 5. This is going to be, well, this is on fraction, but if you want to know how much is it with a decimal number, is going to be 2.6. This is the intersection on x. And then here, if I suppose that x is 0, so this is going to disappear, and then I'm going to have 2y over 13. Y is going to be 13 over minus 2. In that case, it's going to be 6.5 negative. Okay, this is the intersection on y. So let's look for this one. This is going to be 2.6 approximately over here. Okay, and that one is minus 6.5. 1, 2, 3, 4, 5, 6, 6.5 approximately over here. Okay, and then just cross a line between this and this one, more or less like that one, and then I have the graph of equation number 2. As you can see, we have an intersection. Remember, what is the solution? We got x equal to 3, y equal to 1, and it was unique solution. Remember, unique solution is when we have one intersection. Remember, infinite number of solution is because both equations are going to be the same line. And without solution or no solution is when we have a parallel line. In that case, we have a unique solution. And look at this. If I look for this point 3, 1, this is going to be 3, 1, and look at this. This is the solution, 3, 1. And this is the way that I can confirm that the solution that I calculate by equality method, by substitution method, and by elimination or reduction is going to be right. This is the analytic form to verify the solution through the substitution, and this is going to be the graphic form to verify that solution is right. Finally, the only thing that I'm going to say is that when you try the three methods that I showed you, that I have already showed you, if you have numbers with x or y and y, sorry, it means that you have a unique solution, okay? But if you have with using the techniques, and then in one moment of the algebraic operation you have something, for example, like x equal to 4, well, when you have something like that, you can see that this is not true, okay? This is an inconsistent because 0 is not equal to 4. So when you have something like that, 0 equal to something different of 0, is because you are working with no solution case, okay? But if you have something like a 0 equal to 0, this is true, this is consistent. But when you have this one using the methods, it's because you are working with case number 3. Okay, so it's very important that you know how to interpret every case and how to focus every case using the methods. All right, which methods? I'm talking about elimination, substitution, and equality, and finally confirm with the graphic method.